Hi, 7th grade. Welcome to lesson 8.5, solving problems involving circumference of a circle. By the end of the lesson, I want you to be able to say, I can solve problems involving radius, diameter, and circumference of circles. We're going to skip right to the first example. Describe parts of a circle and find circumference to solve problems. So Mark recently replaced his front bicycle wheel. How far does Mike travel with each revolution of his new front wheel? So they tell us the diameter. First of all, we need to make sure we know what the diameter means. The diameter is the distance across the circle through the center. So diameter is all the way across through the middle. The radius is the distance from the outside of the circle to the center. So the radius is half of the diameter. So there's a bunch of radii. These are all radii all around the circle. And there's also a bunch of diameters. Diameter just means it goes straight across the circle. Radius just means it goes halfway. The circumference of the circle is the distance around the circle. So the circumference is a fancy way of saying the perimeter of a circle. And there's also a formula for perimeter, the circumference of a circle, and it's C equals pi d. But I want you to learn another formula at the same time. C also equals pi 2r. Okay, that will come in handy for us later on. But you should know where the 2r and the d are related. D is equal to 2r. So I can replace 2r, not r2, r2d2. 2r. Because the diameter is all the way across, while the radius is half of that. It would take one radius, two radius to make a full diameter. So instead of C equals pi d, we could think C equals pi 2r. Another way to remember that the circumference is pi d is I like to think cherry pie delicious. Some students from last year did not like cherry pie, so they remembered cherry pie disgusting. Whatever works. Use the circumference formula to calculate the distance around the wheel. Here they give us the diameter, so we're going to use the formula with diameter in it. Cherry pie delicious. So first step, write the formula. C equals pi d. Second step is to substitute, to plug in what we know. So we know that the diameter is 26. So instead of d, we're going to put in 26. So the circumference is exactly 26 pi. Remembering that pi, just like on Pi Day, is 3.14, March 14th. So we can also substitute 3.14 for pi and multiply to get an approximation. So the distance around the wheel is about 81.64 inches. So the bike travels about 81.64 inches with each revolution of the wheel. So each time the wheel turns, he goes about 81.64 inches. Let's try it. What is the circumference of the rim of a basketball hoop with a radius of 9 inches? Okay, well, cherry pie is delicious. Circumference equals pi d. But look, they gave us radius of 9 inches. R equals 9. So we can do one of two things. We can remember that if r equals 9, this side's also 9. So the whole thing is 18. So we can do C equals pi times 18. Or you can remember my other formula, C equals pi 2r. Why do I always write that backwards? Pi 2r. So then we get C equals pi 2 times the radius was 9. And 2 times 9 equals 18. Look, we got the same answer both times. So what they are trying to get you to do is multiply the radius by 2 to get the diameter of 18 inches. Then multiply the diameter by 3.14. So we did not do that part yet. So instead of pi, we can plug in 3.14 and multiply that by 18 to get the circumference of about 56.12 inches. Oh, 5.2, I'm adjusting here. 56.52 inches. If the diameter is doubled, what happens to the circumference? Well, if the diameter is doubled, that means it's multiplied by 2. So that means the circumference also gets doubled. All right, example number 2. Find the diameter using circumference. So this is going to be working backwards, but still using our formulas, cherry pie delicious, or remembering that cherry pie radius times 2. 2r. I did it again. 2 times r. The diameter is also 2 times r. Not that it matters. Remember, multiplication is commutative. All right, so they want us to use 3.14 as an approximation for pi. They tell us the circumference is 220. We want to find the diameter, so I'm going to use this first formula anyways. So they write the formula. That's the first step. Then the second step is to substitute what you know. We know that 220 is the circumference, and we know that 3.14 is pi. Now we want to solve for d. That 3.14 is bugging the d. So we want to divide both sides because it's multiplication using the inverse operations. It cancels out on the right-hand side, and 220 divided by 3.14 is about 70. Another way to do this is to also use 22 divided by 7 as pi. If you do 22 divided by 7 in your calculator, you get something close to 3.14. So they use it as a fraction, same thing, still substituting in 220, and then substituting the 22 over 7 for pi. But now, instead, we have a fraction. So we don't want to divide by fractions. Instead, we can multiply by the reciprocal, keep, change, flip. So the 22's cancel each other out, and the 7's cancel each other out, and we still get the answer of 70. So Kayla and Theo will about 70 feet above the ground when they're at the top. Because the top, they would be here. Let me use a different color. The top, they would be here. That is the diameter all the way across. Example 3, use circumference to solve a problem. The larger gear turns twice per second. It causes the smaller gear to turn. How fast does a smaller gear turn per second? So we need to find the difference in their circumferences, how much they go around. So the circumference formula to find the circumference of the larger gear and the smaller gear. For both of them, they give you all the way across, so that's why we can use c equals pi d. Pi is 3.14 for both of them, but we have different diameters. The large gear has a diameter of 6, and the smaller gear has a diameter of 2. When you multiply, the larger gear has a diameter of 18.84, and the smaller gear has the diameter of 6.28. So in order to find out how many turns the smaller one takes, when the bigger one takes one turn, we divide. 18.84 divided by 6.28 gives us 3. So the smaller gear makes 3 full turns for every 1 full turn of the larger gear. But remember, it turns twice per second, the larger one does. So we have to double it. 3 times 2 equals 6, so the smaller gear makes 6 full turns per second. Try it. The circle has a circumference of 9.42 units. So I'm already thinking circumference equals 9.42. What is the area of the square? Well, if you notice, one side of the square is the radius. So I'm thinking about my cherry pie being delicious, but I'm thinking about the fact that I don't know radius, or I don't know diameter, and I'm trying to find the radius. So I'm going to use my formula cherry pie to r, because diameter is the same thing as 2 times the radius. Now I'm going to plug in what I know. I know that 9.42 is the circumference. They want us to use 3.14 for pi. We have 2, and I don't know what the radius is. So now I'm going to multiply 3.14 times 2 to get 6.28 r. I want to solve for r. Right now 6.28 is being multiplied to r. So I'm going to use the inverse operation and divide it. Cancels out on the right hand side. And r equals 1.5. Great, am I done? Did I answer the question, what is the area of the square? No, all I did was find the radius. But area of a square is length times width. And in a square, all of the sides are 1.5 because they're all the same. So area equals 1.5 times 1.5, which equals 2.25 units squared. All right, key concept. The parts of a circle and their relationship are summarized in the diagram below. The radius is half of the diameter. So it would take 2 radii to add up to the diameter. The circumference is the distance around the circle. It can be calculated using the formula c equals pi d or c equals 2 pi r. We like to use c equals pi 2r. Doesn't matter, we can switch the order. The ratio of the circumference of a circle to the diameter is pi. The value of pi is approximately 3.14 or 22 divided by 7. All right, 7th grade, let's say it. I can solve problems involving radius, diameter, and circumference of circles. Have a great day.